So let's have a look on some examples of study. Okay, so case study number 1, you are formulating a new nanoparticle-based product for anti-cancer treatment. The nanoparticles are made of biopolymer polyhydroxybutyrate or PHB by using different types of excipients or a different type of surfactant. So formula number 1, you use PHB and 1% PVA. This 1% PVA is the excipient. Formulation 2, you use PHB plus 0.1% twin AT. And formulation 3, you use PHB plus 0.5% vitamin E TPGS. Okay, if you notice here, the PHB remain the same. Okay, the PHB does not change. Okay, the type of polymer is not changed, but the type of excipients change. Okay, so you want to see if the different type of excipients will produce a different particle size. So let's have a look. So formula A will produce a particle size of 250 nanometer. Formula B produce 280 nanometer, and formula C produce 220 nanometer. If you look based on the numbers, how can you know whether the difference are significant or not? If PVA will produce a better PHB nanoparticles, or vitamin E TPGS give the best particles. Okay, so if we want to know the difference, the significance of the difference, we can use ANOVA. Okay, because there's 3 formula, so we will be able to use ANOVA, and we will know the significance, or whether the difference between each formula are significant. If you have only 2 formula A and formula B, you can use a t-test, okay, to see the difference between the 2 formula. But if you have more than 2 formula, 3 formula and above, you can use analysis of variance or ANOVA. So what is the importance of standard deviation? The standard deviation here will tell us the repeatability of the formula. So if the standard deviation is very big, it means that the formula does not produce particles with the size that are consistent. Okay, so it is very important in a formulation to have a formula that is consistent. Okay, so a smaller standard deviation will tell us that the component of the formula is stable, okay, and will produce a consistent product. So let's have a look on the second example. In case study number 2, you are formulating a new nanoparticle-based product for anti-cancer treatment. Okay, the same. The nanoparticles are made from polymer PHB, the same. And you want to evaluate the effect of 2 processing steps. Step 1 is miling, and step 2 is homogenization. You want to know if homogenization is significant, okay, in producing a better particle size. So you noted that the particle size after miling alone is 405 nanometer, but after homogenization and miling, you get a particle size of 370 nanometer. So how would you know if the difference between the particle size are significant? So you can use a PET t-test before and after the process. So you want to know here whether the homogenization will produce a significantly smaller particles.